Hello, Applied Physics students. This is Mrs. Krumschreider with your Concept Development Practice page 13.2 teaching video. This is about force and weight. Remember, weight is really the pull of gravity on a certain amount of matter. So, number one, an apple that has a mass of 0.1 kilogram has the same mass wherever it is. The amount of matter that makes up the apple, blank the location of the apple. Remember, the amount of matter does not depend upon the location. Okay? So an apple is always an apple and has the same amount of matter no matter where it is. It has the same resistance to acceleration wherever it is. Its inertia everywhere is the same. Remember, inertia is really kind of a measure of mass. So we have the same mass everywhere, we have the same inertia. The weight of an apple is a different story. It may weigh exactly 1 Newton in San Francisco and slightly less in Mile High, Denver, Colorado. On the surface of the moon, the apple would weigh 1/6 Newton, and far out in outer space it may have almost no weight at all. The quantity that doesn't change with location is mass. Mass is always the same. And the quantity that may change with location is its weight. That's because blank is the force due to gravity on a body. That's because weight is the force due to gravity on a body, and this force varies with distance. So weight is the force of gravity between two bodies, usually some small object in contact with Earth. When we refer to the blank of an object, we are usually speaking of the gravitational force that attracts it to Earth. When we talk about the weight of an object, we're talking about the gravitational force that attracts it to Earth. If we stand on a weighing scale and find that we are pulled toward Earth with a force of 500 newtons, then we weigh 500 newtons. Strictly speaking, we weigh 500 newtons relative to the Earth. How much does Earth weigh? If we tip the scale upside down and repeat the weighing process, we can say that we and Earth are still pulled together with a force of 500 newtons. And therefore, relative to us, the whole huge mass kilogram Earth weighs 500 newtons. Weight, unlike mass, is a relative quantity. So, again, we are pulled to the Earth with a force of 500 newtons, so we weigh 500 newtons. Earth is pulled towards us with a force of 500 newtons, so it weighs 500 newtons. So, again, that's kind of differentiating between force and weight, and mass and weight. And again, it's mass that stays the same no matter where you are on Earth or in the universe, because it's the measure of the amount of matter that an object contains. Weight changes depending upon the gravitational force between the objects.